Okay, in this section what we're going to do is we're going to look at something, it's kind of like a review. It might be for some of you, it may not be for some of you, but it's necessary when we look at some of the properties involving rational functions. And when we look at rational functions in a little bit more detail. So those are the additional sections in Chapter 5. So before we go back to those 5.3 and 5.4, I believe they are, we have to look at polynomial long division. So you could divide polynomials by other polynomials, just as the same as numbers using long division. You know, for example, if you did 213 divided by 7, well, you would write that, you know, this means divide 213 by 7. So you would do this, you know, without your calculator, obviously. You would do 7 goes into 213. So this right here is the divisor. This right here is called the dividend. And the result, your answer, will be the quotient. So you learn how to do long division in grade school. I'm just writing this out for reference so you can see the idea behind it. So you would say, how many times does 7 go into 2? Well, it doesn't. So then go to the next one. How many times does 7 go into 21? 3 times. 3 times 7 is 21. Subtract that from the dividend. You're going to get 0. Bring down the 3. 7 goes into 3 how many times? 0 times. So put that in the quotient. 0 times the divisor is 0 times 7 is 0. 3 minus 0 is 3. I have nothing left to come down, so this is the remainder, which means my quotient is 30 with a remainder over my divisor, which is 3 over 7, which is 30 and 3 sevenths. You can check that on your calculator, right? 213 divided by 7, 30.428574143. Well, 3 over 7 is what? It's that decimal. So that's how you would do that. So you could do polynomial long division the same way. Alright, so divide this by this. So we're going to set it up the same way. X squared plus 1 is the divisor. And that goes into the dividend, which is 3x cubed plus 4x squared plus x plus 7. So when you're doing this process, you're following the same logic. You're asking yourself, how many times does x squared go into 3x cubed? That's what you're asking yourself. How many times does x squared go into 3x cubed? Well, in other words, what's missing? If I multiply x squared by what to get 3x cubed, what is it going to be? It's going to be 3 times x, right? 3 times x, 3x times x squared gives me 3x cubed. So the 3x is going to be part of the quotient. Right? 3x 3x times x squared is 3x cubed. This times this goes down below here. Just like it did here. 3 times 7 is 21. Now, because I didn't multiply my whole divisor yet, I still have another term. 3x times positive 1 is plus 3x. Okay. Now, what you're going to do next is you're going to subtract the 21 from the dividend, right? And that's the next step in the long division process. So you're going to subtract the whole thing from the dividend. Okay, so let's do that. Now, so 3x cubed minus, now don't forget to put parentheses here, because if you forget to do that, your long division is going to be incorrect. So 3x cubed minus 3x cubed is 0. That's good. If you get a 0 there from the leading polynomial terms, that means you're doing it correctly thus far. Now 4x squared minus 3x, well, you can't subtract those. You can't subtract those. So what's going to happen there is you're going to have to bring that down. What you're going to have is you're going to have 4x squared minus 0, which is just positive 4x squared. Actually, to make this a little bit less confusing, let me do this. Sorry about this, guys, because you're probably a little lost right now. Just bear with me. So, let me extend this. So, when I do this, 3x times x squared, I got 3x cubed. All right, I got 3x cubed right here. Now 3x times 1 is 3x, right? So I'm not going to put the 3x underneath the 4x squared part because they're unlike terms. In other words, I'm going to keep these terms aligned based upon their powers, okay? These are the x cubed terms. These are the x squared terms. This is the x terms. This is the constant term, okay? So what I'm going to do, since 3x times 1 is going to be positive 3x, I'm going to align that underneath the x term. So now when I subtract the whole thing, I could just keep track of my x cubed terms, my x squared terms, and my x terms. That way it's not as confusing. Sorry if I misled you there. I didn't mean to do that. Okay? And, I'll do more examples, so don't fret too much. So now that I know that 3x cubed minus 3x cubed is 0. All right? Positive 4x squared minus, well, I don't have anything. I have a 0 x squared term here. I don't have an x squared term here. So basically, I could just have 4x squared minus 0, which is positive 4x squared. I'm just keeping the, I'm just keeping the terms aligned. Basically, that's all I'm doing. That's all I'm doing. And now x minus positive 3x becomes negative 3x. So that's x minus 3x, which is negative 2x. Okay, so now that I did that, I subtracted this from the dividend, I could bring the 7 down. Just like I did here, I brought the 3 down. And now you repeat the process, right? How many times does 7 go into 3, right? How many times does x squared go into, now the leading term here is now 4x squared. I don't care about the 0 here because that's been reduced. So how many times does x squared go into 4x squared? Well, that's just 4, right? That's going to be plus 4, right? X squared times 4 gives me 4x squared. So that's going to be plus 4. 4 times 4x squared is 4x squared. I'm going to align that with the x squared terms. 4 times 1 is 4. I'm going to align that with the constant term. All right, I keep my terms aligned. Subtract the whole thing from my dividend. Okay. Plus 4x squared minus 4x squared is 0. That's good. When you get that 0, that means you did it right. Negative 2x minus 0. This is just 0 right here. I have a 0x term here. So negative 2x minus 0 is just negative 2x. And then 7 minus 4 is 3. Okay. Since I have nothing else left to bring down, what do you think the negative 2x plus 3 is? That's my remainder. So how do we write the remainder? Well, we don't write remainder. We write the remainder over the divisor, right? So my quotient, so since this is negative 2x plus 3, I'm going to have my remainder, which is negative 2x plus 3 over my divisor, which is x squared plus 1. So my quotient, or my answer, right, when I divide this polynomial by x squared plus 1, I get 3x plus 4. That's the part that divides evenly. That's the 30 part. Plus my remainder, which is negative 2x plus 3, over my divisor, which is x squared plus 1. So that right there is my answer. I'm sorry about this part right here. I got a little ahead of myself. The idea with long division with polynomials is to keep all the powers aligned. X cubed, x squared, x, constant. All right? Just keep them aligned so that when you do the subtraction part, you don't get confused. There are a lot of examples with these things, and you know, it does take a little practice to do long division with polynomials, but it really isn't that bad once you get the hang of it. And the reason why you need to do this is because when we look at rational functions in more detail, this technique is important. Okay, let's look at this example here. So divide this polynomial by that. So when I set it up, I'm going to have x squared plus 2 goes into 5x to the 4th minus x squared plus x minus 2. So I went a little too far there. Okay. Now I want you to notice something here. Remember how I said I want you to keep track of all your powers here? Well, if I look at my powers here, what do I have? I have x to the 4th, then I go to x squared, then I go to x, then I go to my constant. What power is missing? X to the 3rd is missing. So if I look here, if I look at my dividend, x to the 3rd power is missing. All right, I want you to notice that. So here's what you need to do. Note, if a term is missing, like in this case, you know, when you go with descending order, right? X to the 4th, and then x cubed should be next, but it's not there. So if a term is missing, like x to the cube is here, you have to account for it by writing a placeholder. So if a term is missing, you need to account for it by writing a placeholder for the missing term. So in this case, what I'm going to do is I'm going to write 0x cubed. I'm just going to write a placeholder so I can keep all my terms aligned. So this keeps my powers aligned properly so I can perform the long division. Okay. So what I'm going to do is I'm going to rewrite this as x squared plus 2, and my dividend is now going to be 5x to the 4th, and I'm going to write my placeholder plus 0x cubed, and then I'm going to write the rest, minus x squared plus x minus 2. This way I have all my powers accounted for here in my polynomial that I'm dividing. And that way when I do the long division, it's not as bad. Okay, now the long division process is the same. How many times does x squared go into 5x to the 4th? In other words, what's the missing factor? X squared times what gives me 5x to the 4th? X squared times question mark gives me 5x to the 4th. Well, that's going to be what? 5x squared, right? 5x squared. 5x squared times x squared is 5x to the 4th. I'm going to align that with the x to the 4th terms. And then 5x squared times 2 is going to be what? So I'm going to multiply this by 2. And that's going to give me 10x squared. So I'm going to write that underneath the x squared terms. Okay? Now I'm going to subtract that whole thing from my dividend. Alright. 5x to the 4th minus 5x to the 4th gives me 0. That's good. That's good. 0x cubed minus 0 is just 0. So I don't have to worry about that. That's fine. Remember, that's just a placeholder. That's just there to keep track of my long division. Alright. Minus x squared minus 10x squared is going to be, when I distribute the negative here, I'm going to get minus 10x squared. So minus 11x squared minus positive 10x squared that's going to be minus 11x squared. Alright. Now I'm going to bring down the next term, which is plus x. Now you just repeat the process again. Just repeat the process again. So x squared times what? Times question mark gives me negative 11x squared. Negative 11, right? That goes in my quotient. So negative 11 times x squared is negative 11x squared. And then negative 11 times 2 is negative 22. And that's going to go underneath my constant term. Right? That's going to go underneath my constant term. So now I'm going to subtract that. Oop, I put that outside the wrong. Wait, no, sorry. So yeah, x squared times negative 11 is negative 11x squared. Negative 11 times 2 is negative 22. Now I'm going to subtract that whole thing. Alright? Negative 11x squared minus negative 11x squared is positive 11x squared. Remember, that leading term should become 0 now. And it does. I just put a little slash through it to indicate that I'm good. x minus 0, because right here I have a 0 term, right? This is a 0. I have a 0x term here. So x minus 0 is just x. And then I have what? So then I have negative 2, right? I have negative 2 minus negative 22. So negative 2 minus negative 22, that's just negative 2 plus 22, which is what? Plus 20. All right. Now, how do I know I'm done? Well, again, my constant term was already accounted for when I did, I already brought that down because I had a negative 22 here. So I'm combining that constant term with the constant term in my dividend. That's how I know I'm done. I have no more terms to bring down. So this right here is my remainder, x plus 20. That's my remainder. I'm done with the division process. So my remainder is written over my divisor. So I have plus x plus 20 over x squared plus 2. That's my remainder of my division. So my quotient, in other words, when you divide this polynomial by x squared plus 2, you're going to get the following. 5x squared minus 11 plus x plus 20 over x squared plus 2. So whenever you're doing long division of polynomials, the big thing you want to remember is to keep track of the powers. Right? Keep track of the powers. That's the big thing you want to do. By keeping track of the powers, you could keep track of the terms when you go through the long division process. It might seem a little overwhelming at first, but it requires practice. It does. I suppose I could do one more example. I don't have them in the notes, but I'm sure I could find one in the textbook. Since I'm such a softie, I'll do another one. Let me just look it up. All right, here's an example. Make sure I don't write down the same one I just did, right? Let's see here. 2. Hold on, guys. I'm looking for a good one here. In some ways, your textbook is really stupid. And so when I make my notes, I be very careful. All right. Divide (15x to the third) minus 4x squared minus 24x minus 11 by 5x plus 2. All right, so let's set that up. Five x plus 2 goes into now 15x to the third. So look at the powers. I have x cubed, x squared, x, and a constant. So I don't have to put a placeholder here because all the powers are accounted for. All right. So how many times does 5x go into 15x cubed? You know, how many times does this value go into this value? So that's going to be what? 3x squared? All right, 3x squared times 5x gives you 15x cubed. 3x squared times 2 is 6x squared. Notice how I put it underneath the x squared terms. So subtract the whole thing. This first term is 0. 15x cubed minus 15x 0. That's 0. I put a little fancy 0. That's just me. That means I'm doing it all right. Minus 4x squared minus positive 6x squared. So you distribute the negative. It makes it negative 6x squared. That becomes negative 10x squared. Bring down the negative 24x. All right, repeat the question. How many times does 5x go into negative 10x squared? So what? Negative 2, right? And then, so minus 2, and then what? X times x gives me x squared, so minus 2x, right? You know, minus 2x times 5x is negative 10x squared. So that times that gives me negative 10x squared. And then negative 2x times positive 2 gives me minus 4x. That goes underneath the x terms. Subtract the whole thing. Negative 10x squared minus negative 10x squared. That's positive 10x squared, so that gives me 0, which is good. Negative 24x minus negative 4x, that's positive 4x. So negative 24x plus 4x is negative 20x. Bring down the negative 11. All right. Repeat the question again. How many times does 5x go into negative 20x? Well, it's going to be minus 4, right? All right, minus 4 times positive 5x is negative 20x. Minus 4 times positive 2 is negative 8. I put that underneath the constant value. Subtract the whole thing. Negative 20x minus negative 20, that's a positive 20x. That gives me 0. Negative 11 minus negative 8, that becomes positive 8. So negative 8 plus, or I'm sorry, negative 11 plus 8 is negative 3. Since I have nothing else left to bring down, that is my remainder. So my quotient, so it's going to be, I'm going to write plus negative 3 over 5x plus 2. So my quotient, when I divide this polynomial by 5x plus 2, I get 3x squared minus 2x minus 4 plus negative 3 over 5x plus 2. That's it. That is it. In other words, if I multiply this by 5x plus 2, I'm going to get this quadratic. I'm going to get that polynomial. Because the opposite of division is multiplication. All right. So that's long division of polynomials. I showed you 3 examples. It does take a little practice, but as long as you keep the powers aligned, you'll be fine. I think that's the only confusing part. I kind of confused myself here by not keeping track of it initially. But as long as you keep the powers aligned, you'll be okay. It's the same process as long division with numbers. It really is. So, it's important that you master this, because this does show up a lot when we look at rational functions in a little bit more detail. So, that's the end of this video.